Hello viewers, welcome to the another interesting segment of digital communication. In the earlier segment we have discussed probability basic. Now in this segment we are going to discuss probability advanced. So a warm welcome to all of you, and the lecture is totally conducted by Ganon powered by Wishback. I am Professor Oritra De. In this segment we are first going to discuss the sample space. What is a sample space? In a coin tossing experiment, the sample space is head and tail, which is a domain of random variable. The value assigned to head is +1 and to the tail is -1. They are known as range of random variable. The probability of getting head or tail is half. The graph shows how random variable is a function from all possible outcomes to real values. It also shows how random variable is used for defining probability mass function. Hence, a random variable's possible value might represent the possible outcomes of a yet to be performed experiment, or the possible outcome of a past experiment whose already existing value is uncertain. Now let us discuss the category of random variable. Random variable can be classified as discrete random variable, or it may be continuous random variable, and which are the in continuous random variables that can have any values within a continuous range, and in discrete random variable have specific values. Now let us define this discrete random variable and continuous random variable in more detail. In discrete random variable, as the name suggests, discrete random variable consists of distinct or discrete unique values. In discrete random variable, as the name suggests, discrete random variable consists of distinct or discrete unique values. It takes a countable number of distinct values. Now consider in an experiment where a coin is tossed 5 times. If x represents a number of times that coin comes of heads, then x is a discrete random variable that can only have the values 0, 1, 2, 3, 4 and 5. No other value is possible for x. Discrete random variable, then what is the example for a discrete random variable? Tossing a coin. Here the number of outcomes that can occur is either a head or a tail. Hence we can denote head, tail as random variables as they are distinct in nature. Now let us discuss continuous random variable. An example of a continuous random variable can be experiment that involve measuring the amount of rainfall in a city over a year, or the average height of a random group of 25 people. What is the example of continuous random variable? Height of the people playing basketball. Here, height can be values between 4 feet to 7 feet respectively. Now let us discuss cumulative distribution function, or CDF. CDF of random variable capital X takes values less than or equal to small x is defined as capital F suffix capital X, X is equal to probability capital X is less than or equal to small x. What are the properties of the CDF? Number 1, CDF bounded between 0 and 1. So capital F suffix capital X, X lies between 0 and 1. Fx infinity is equal to 1. And the third property is Fx minus infinity is equal to 0. Now let us discuss probability density function, or PDF, which is small f suffix capital X, X is equal to ddx of Fx, X. What is the properties of this PDF? Properties of the PDF is number 1, capital F suffix capital X, X is equal to integration minus infinity to x small f suffix capital X, X dx. Number 2 property is small x suffix capital X, X is greater than or equal to 0. Number 3 property is integration minus infinity to infinity small f suffix capital xx dx is equal to 1. Now let us define the relation between probability and PDF is given by P capital X lies between x1 and x2 is equal to integration x1 to x2 f suffix capital xx dx. Now let us discuss nth moment of a random variable of x, which is capital E x to the power n is equal to minus infinity to infinity capital X to the power n fxx dx. Then what is the first moment of x, which is known as mean value, is ex. Here n is equal to 1, as simple as that. Is equal to integration minus infinity to infinity capital X small f suffix capital x x dx. It is also known as dx is equal to known as mx. The second moment of the x, which is known as mean square value, is e capital X square. In this case, n is equal to 2 is equal to minus infinity to infinity x square small f suffix capital X x dx. The central moment is capital E within bracket x minus mx to the power n is equal to integration minus infinity to infinity within bracket capital X minus mx to the power n fxx dx. Hence, let us discuss the variance of a random variable capital X, which is E within first bracket capital X minus mx square is equal to sigma x square is equal to integration minus infinity to infinity within first bracket capital X minus mx square fxx dx. So, sigma x square is equal to ex square minus mx square. So, what we have discussed in this segment? In this segment, we have discussed random variable, category of the random variable. After that, we discussed mean square, and the moment of a random variable. That's all for this segment. Stay tuned to Gyanon. Bye.